Alright, so here's how to solve a problem.
3.50.
And the problem is asking for is to apply mesh analysis to determine the value of Vx, which is the voltage drop across this resistor. And so uh, for this problem, super meshes aren't really necessary, and so the concept won't be explained with this video, but mesh analysis will. Just regular meshes. So a mesh, you can see there's 4 meshes that you can make with this problem. We have one over here, one over here, got one over here, one over here, and one over here. Let's make that with some non-intrusive loops. So we have this first one, which we're going to call with the current going through it of I1. Holy moly. Let me actually close that out completely. I'll come back to it later. That's I2. I2. As a default, we're making them all clockwise for no good reason. I3. And I4 is going to be the opposite direction. You'll see why. I1, so we have 4 unknowns, and the goal here is to make a system of equations, of 4 equations, where you can solve for them with the 4x4 matrix. Except I1, we can make this a bit easier, because I1 is given to us. It's 1 amp. So all 4 of these sides that I1 touches has a 1 amp current going through it. So I2, let's see about I2. So I2, let's follow the loop. Let's start with the 2 ohm resistor. So 2 ohms times I2. That gets you the voltage drop across the 2 ohm resistor. And so that's, 2 ohms times I2. And what we're making is a KVL equation. So hopefully all of these voltage drops across all of the resistors and this power supply will equal 0 in the end, will net you 0. So 2 ohms times I2 plus 3 ohms times I2 minus the 2 volts. And the reason it's minus is that we're going from the negative to the positive terminal, and it's a voltage source that supplies power while these resistors consume power, sort of consume voltage, while this voltage source obviously supplies voltage. But for the sake of simplicity, we're sort of inverting it. And so all the resistors, for the sake of making them positive, we make the voltage source negative. And so we have negative 2 volts plus, now this 5 ohm resistor is where things get a bit complicated because it shares a side. So we have 5 ohms times I2, but we also have minus I1 because as we traverse I2, as we traverse the 5 ohm resistor upwards, it follows I2, but it opposes I1 at the same exact time. So we have I2 minus I1, and that whole thing is equal to 0. What you can see here is that there's only one unknown, because I2, I1 is known, and so we can solve for I2, and long story short, what you get in the end is I2 is equal to 7 over 10 amps. So let's move on to I3. For I3, let me make this split screen and get a bigger view. And left-handed. So hopefully you can see here, I3. So I3, we have the 4 ohm resistor. Let's start with that. That shares, so I3, but it shares a side with I1, which goes in the opposite direction of I3 at the same time. As I3, as we travel in the clockwise direction for I3, that means we're traveling in the counterclockwise, also in the clockwise direction, but since it's the bottom side, going to the left for I1. And then we have the 3 ohm resistor, 3 ohm resistor, here's where things get complicated. It's I3 plus I4. And that's because I4 is also going down, because we have I4 going counterclockwise. You can have any direction you want. The reason I made I4 counterclockwise is so that it follows the same voltage source that we have in I2. Going from negative, it's nice to have the current travel from high potential to low potential. That's about it. So I3 plus I4. And then you have the 2 ohm resistor, so plus 2 ohms times I3 plus 2 ohms times I3. No other currents affecting these two 2 ohm resistors. And that all equals 0. So again, we have only two unknowns, I3 and I4. So we can rearrange it so that we have I3 times all of the coefficients of I3. So there's 4 ohms plus 3 ohms plus 2 ohms plus 2 ohms. And then I4, what are the coefficients of that? Just as 3 ohms. And then all of the constants, well, I1 is known to be 1. So that's our only constant, is -4. And -4, when you bring it to the right side of the equation, is +4. And again, ohms is an SI unit, and so I'm going to ignore it. And ohms times, and so yeah. So you can add these up to get 11I3 plus 3I4 is equal to 4. That's our first equation. We're only going to need two equations because you can see two unknowns. Only two unknowns, and we're only going to need a 2x2 matrix, which is, while a 4x4 matrix is doable, this is a lot easier to work with. So now I4, we have, let's go counterclockwise. Let's start with the 2 volt power supply, which we made negative 2 volts, plus 3 ohms times I4 plus I3. Again, I3 and I4 are in the same downward direction because we're traversing it downwards, plus 6 ohms times I4 is equal to 0. And so again, isolate the, or rearrange it to isolate the variables. So I3 times 3 ohms plus I4 times 3 plus 6 ohms is equal to -2 volts. Move to the right side, 2 volts. Volts is also an SI unit, so done. So 3I3, so what we're left with, plus 9I4 is equal to 2. So what we're left with is a system of two equations, 11I3 plus 3I4 plus 4. And so let's make a matrix. So we have 11 and 3, and then we have from here 3 and 9. So 3I3 times 9I4, and then I3, I4 is equal to, what are the right sides of these equations? 4 and 2. And so this equation, this is equivalent to saying 11I3 plus 3I4 is equal to 4, 3I3 plus 9I4 is equal to 2, and then you can solve the system of two equations. So we can do this in MATLAB. So let me move over there. Oh yes, and
Before we
move on to MATLAB actually. We are not solving for I3 and I4 necessarily. The problem asks to solve for Vx. And what we can see from this resistor is that Vx is equal to the voltage drop across that resistor, which is 2 ohms times I3. So, but actually, it goes from low potential to high potential, so it's actually the opposite direction, so negative. And so what we have is I won't put the negative there, I'll put the negative to the Vx. So what we have is Vx is equal to 2 ohms times I3. All we need to do is solve for I3, and we have our answer for Vx. So let's move on to MATLAB now.
Alright, so apparently Windows forgot to connect my microphone, so I'm recording this voiceover after the fact. Welcome to MATLAB. So this is a pretty simple equation that you could do by hand, but I'm doing it in MATLAB anyways. Anyways, he's writing the left equation. The equation is set up in AX equals B format, and so the left matrix is that 2 by 2 matrix that you saw. You can see the first row is 11, comma, 3, and then the semicolon, second row, 3, 9, and then you have the right equation, which is, the right matrix, which is that 2 by 1 vector with the constants, which are 4 and 2. And then the way that you solve for it is by using linsolve. Oh, he's yapping about AX equals B, the thing that I just explained. So let's let him run his course, blah, 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 blah. All right, linsolve. There we go. Linsolve, left, right, and he'll demonstrate that it achieves the same effect as inverse of the left times multiplied by the right side equation, or the right side vector. And now we have I3. Solving for I3, I3 is the first entry, or the first number that you get from the vector, the resultant vector. And so you can have, so I named the resultant vector x. And so x, the first entry of x and the second entry of x. And then he's also explaining that Vx is equal to 2 times I3, and negative 2 times I3, which is negative 2/3. Boom.